The radiation corresponding to 3 towards 2 transition of hydrogen atom falls on a metal surface to produce photoelectrons. These electrons are made to enter a magnetic field of 3 into 10 raised to minus 4 Tesla. If the radius of the largest circular path followed by these electrons is 10 millimeter, the work function of the metal is close to. Let us try to understand the situation physically through this diagram. In this case, it is given that transition of the hydrogen atom is from n equal to 3 to n equal to 2. In the case of hydrogen atom, we know that the various value of n correspond to the energy levels. N equal to 3 corresponds to energy of minus 1.51 electron volt. N equal to 2 corresponds to energy of minus 3.4 electron volt. So when the electrons makes transition from 3 towards 2, the energy of radiation will be equal to, so we can write that energy that is incident from this transition is equal to final, that is E of 2 minus E of 3. So that is equal to minus 1.51 minus of minus 3.4 electron volt. So this comes out to be minus 1.51 plus 3.4, so it will be equal to 1.89 electron volt. Now this is the energy of the incident radiation. That is what we can see over here. This radiation will fall on the metal surface. When it falls on the metal surface, a part of this energy of incident radiation will be used up in overcoming the electron attraction of orbital. So that we can say that that is equivalent to the work function. The remaining energy which is left will be taken up by the electron and it will be ejected from the metal surface. That ejected electron will be known as photoelectron. So let us say that energy acquired by the electron, which will be obviously kinetic energy, or let us denote it by E, then energy which is acquired by the electron finally before it moves into the magnetic field, let us say it is equal to EF. So from conservation of energy we can write like this: incident energy of radiation will be used up in two parts. That is, first part will be used to liberate electron, that is equal to work function, which we will denote by phi, and the part of energy which is left out is that energy with which the photoelectrons will be emitted. So we will write that as EF. We require to calculate this work function. So work function can be written as EI minus EF. Now this energy of photoelectron, obviously it is in form of kinetic energy. It enters into the magnetic field and it will trace a circular path. As it traces a circular path of some radius, we know this expression for the kinetic energy of the electron, Kf, can be written as E square R square B square by 2m, where E is charge of electron, R is the radius of circular path, B is the magnitude of the magnetic field in which it is moving, and m is mass of electron. Keeping these values, you will get kinetic energy in joule, which can be converted into electron volt by dividing with E. We can get the kinetic energy of the emitted photoelectron as 0.79 electron volt. The calculation part is left out for the student to complete. It would be too tedious to show it over here. But the method is something like this, and the unit is very important. This will be giving you the energy in unit joule. You have to divide it by value E to get it in the unit electron volt. Now subtracting these two, we can get that work function of metal is equal to 1.89 electron volt minus 0.79 electron volt. So that gives us work function 1.1 electron volt. We can say that option A is satisfying the given condition.